Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 26th video in the Introductory Programming in Java full course and the first video of Lesson 5, Static Methods in Java. In this video, we'll discuss what a method is and look at some examples. Let's get right into it. A method is a block of code that has a name. Once defined, a programmer can use that name everywhere it's available to execute the block of code. Further, a method can take parameters that specialize the way it works, and it can return a value which is the result of the work it did. If you're familiar with any other programming languages, you might have learned about this concept but used the name function, procedure, routine, or subroutine to refer to a named block of code. In Java, they're called methods, but the overall idea is the same. Methods are used to reduce the complexity of a large software system. Most of our examples will be small, so you can focus on the method's syntax and how it is working. But in a later video in this lesson, we'll solve a slightly larger problem so you can see how breaking a problem into methods can make the solution easier to understand, debug, develop, and modify. Let's look at an example. In earlier videos, we saw a quiz program example that presented one question to the user and allowed the user to answer until they answered correctly. Here's one version of the program called simplequizloop.java. I'm going to run it. Now it poses a question and the correct answer is C. If I give a wrong answer such as A, it will give me some feedback and let me try again until I give the correct answer. I'll answer C. I'm going to rename the program to simplequizMethod by selecting the class name, right-clicking, and choosing Refactor Rename. I'll rename it and press Enter. Notice that the file name changes as well when I do this. If you want to change the name of a variable, method, or class in a program, use refactor so that it will be changed everywhere it's used and Eclipse recognizes the change. This program is a good candidate for decomposition into methods. For example, we could write a method that asks the question and gets a valid response from the user, simplifying the loop in the main method. If we write a general method that we can specialize with parameters, we can write a method that can ask any quiz question and enhance the program to ask many questions without writing a lot more code. I want to introduce a diagram called a structure chart that can be used to represent programs with methods. Right now, our program has one method called main. I represent that with a box with the name main inside. As we enhance this program, I'll redraw the structure chart to show our changes. Let's begin by simply moving the question posing code to its own method within our class curly braces, but above our main method, I'll begin the definition of a new method. I'll start with the familiar public static void. What comes next is the name of the method. Method names follow the same rules as variable names. They may contain letters, numbers, the underscore, and the $sign, but can't start with a number and can't be Java reserved words. They should, of course, be meaningful, and by convention, they should be camel case. Usually a method name contains a verb, since methods are code and therefore do something. I'm going to call this method poseQuestion. Lowercase pose, uppercase Q, lowercase question, and then open and close parentheses, and then open curly brace, close curly brace. The method body, the code that is executed when we use the name poseQuestion, will go between the curly braces. Now I'm going to start very simply here, and then we'll make it more general and interesting. So to start, I'm going to select and cut all of the print statements that print the question and the answers from main, and I'm going to paste them between the curly braces of poseQuestion. And now, where they were in main, I'm going to invoke or call poseQuestion. That means write code to run that method. So to do that, I use the name of the method pose question, open close parentheses, semicolon. So functionally, this program is exactly the same as it was, but the way it executes is different. Let's just run it and enter A and C again to illustrate, not prove or thoroughly test, that it's the same program. Okay, and it functions the same. Let's talk about how it executes now. Execution, as always, begins at main. We declare and initialize the scanner and the variable answer. And then we get to the test for the while loop. It is true because answer, which we initialize to x, is not equal to c, so we go into the loop, and the first line of code in the loop is our method call, pose question. When Java encounters a method call, control jumps to the header of the method and then executes the code in the method body. So control will jump up to pose question, which is simply a series of print statements executed sequentially. They will all execute, and then control returns to where the method was invoked, so back to our call to pose question. Nothing else is happening on that line, so control then proceeds to the lines after, obtaining an answer from the user, providing feedback based on that answer, and then back to the top of the loop. If the user gave an incorrect answer, it will happen all over again. Control will jump to pose question, it will execute, control will return, the program will obtain an answer from the user, and then provide feedback until the user answers correctly. Let's review what we have so far and then enhance it a bit. To define or declare a method, it will need to be inside a class. For now, we are learning about static methods, which means methods that execute without an object of the class being instantiated. Don't worry about that too much. Once we get to the next lesson on classes, we'll be writing non-static methods, and we can discuss the differences. For now, we're creating methods that are part of a functionally decomposed system, a system where execution begins at main and then jumps into methods to accomplish specific tasks before jumping back to main. To define a method inside the class curly braces, we first put the visibility specifier, and for now, all of our methods will be public. Then we put static. Again, for now, all of our methods will be static. The next word, void, refers to what the method returns. We will add a return value to this method by the end of the video. If a method doesn't return a value, like our method right now, we use the keyword void, meaning nothing is returned. We then put the name of the method, following the same rules we learned for naming variables, but the name should have a verb in it, and then open and close parentheses. If the method has parameters, they will go in the parentheses. We'll add parameters to this method next. If a method doesn't have parameters, it still needs the parentheses. And then open curly brace, and all of the code that should execute when the method is called, and then close curly brace. To invoke or call the method, we use the method name followed by parentheses. We'll see how to invoke a value returning method with parameters in a moment. We put that method call exactly where we want the method code to execute. When the Java runtime environment encounters the method call, execution jumps to the method code, and once it has executed, execution returns to where the method was invoked. Here is the updated structure chart for this program. Note that we now have two methods, main and pose question, both drawn within their own rectangle, and there is an arrow from main to pose question. This arrow indicates that main calls pose question. Now let's talk about how this method can be improved. First, it's not a bad method because it takes some code out of the main method. That code is replaced with a method call, which has a name that clearly describes its task. This simplifies the main method. If I want to change the question, or if there's a bug with posing the question, I have a small block of code separate from other code that I can edit. If you can break a program into methods, each with a single clear purpose, then it will be easier to debug and modify your program because you will have less code to examine, debug, and rewrite. This embodies several goals that we have in software design. Divide and conquer, which means breaking a program into separate tasks. Encapsulation, meaning everything that has to do with one task, in this case posing the question, is enclosed in one method. And information hiding, the main method doesn't need to know how the pose question method works. It just calls it and pose question does the job. But the problem with this method is that it isn't general at all. It does one very specific thing. It poses this very specific question. I would like to enhance the method so it can pose any question, for now let's say with 4 answers, A through D, and get a valid answer from the user, which it then returns to the place from which it's called. Such a method is much more useful. It means we can write a different quiz reusing that same method. It means we can pose many questions using that same method. This is generality, the ability to solve many similar problems rather than one specific problem. So to specialize this method, rather than having it print these literal strings, I'll allow the calling method to pass in the strings it should use to pose the question. I'll call them question and answer A, answer B, answer C, and answer D, all of type string. To do that, I put those variable declarations in my parameter list between the parentheses in the method definition. So string question, comma, string answer A, comma, string answer B, comma, string answer C, comma, string answer D. And you can see that's a very long parameter list. Notice that I can spread that over as many lines as I wish. And now there's a little red X where I call pose question. That's because I'm not supplying the required parameters. Let's mouse over it. It tells me the method pose question string, 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 string in the type simple quiz method is not applicable to the arguments open close parentheses. Okay, well, that's Java's way of telling me that my argument list, what's in the parentheses when I call the method, and the parameter list, what's in the parentheses in the method definition, do not match. You'll probably make that mistake at some point, so try to remember it. Now, what I want to pass in is the specific question that the method is asking right now. So I'm going to cut those strings out of the print statements in the method and paste them into where I'm calling the method, separated by commas. I must put them in order, so question followed by answers A, B, C, and D. And I've spread that over multiple lines as well. And once I've got the arguments, the question and answers separated by commas, to match the parameters up in the definition, the red X goes away. Now, back in the method definition, what am I going to print? I'm going to print those variables that are defined in the parameter list. So system.out.println question, system.out.println answer A, system.out.println answer B, and the same for answers C and D. So what's going on here? Well, when we run the program, execution begins at main. We create the scanner, give answer the value X, and execute the test at the top of the loop. Since X isn't C, we go into the loop and invoke pose question. But this time, we're passing in some values, the strings that represent the question we want posed. Execution jumps to the first line of pose question, the method header, where the values we passed in are stored in the parameter variables. So the first value we passed in was the string, what is the complement of 400 less than or equal to CO2 reading, and CO2 reading less than or equal to 800. So that will get stored in the first parameter variable, question. And the other 4 values are stored in answer A, answer B, answer C, and answer D. They are matched by order. The pose question method then poses the question. It prints the question and answer variables, and then execution returns to the main method where the pose question method was called and proceeds as before. Again, functionally, this program works the same as the prior 2 versions. But this is a better design because we now have a more general method that can pose any question. I'll run it again and enter A and C. And you can see it functions in the same way. Here's the updated structure chart. Notice that now we see some data flows, circles with arrows, flowing along our arrow from main to pose question. Those data flows are labeled question, answer A, answer B, answer C, and answer D. The arrows on the data flows show that those values are going from main into pose question. This is how we show parameters in a structure chart. Parameters specialize how a method operates and give it the data it needs to complete its task. Now, let's further improve pose question so that it also obtains an answer from the user, validates that it's A, B, C, or D, and then returns that answer to the main method. Let's write the code that obtains the answer and validates first, and then we'll hook the two methods together through the return value. I'm going to cut the two lines from main that prompt the user for an answer and read it with the scanner and put them up in pose question. Now we get an error because both answer and the scanner object standard in aren't defined. I'm going to declare answer in pose question. This is a separate variable called answer. It is a different variable from the variable in main. Something that is important to know is that the variables declared within a method are visible only within that method, kind of like Las Vegas. So char answer. And for the scanner, I'm going to pass that in as another parameter. I'm not going to go into the pros and cons of that right now. I'm just going to add it to the parameter list both in the method declaration and where I call it as the last parameter. There. Now the errors are gone. And I'm going to write a do-while loop around this to validate that the answer is between A and D. So do before all of the print statements in method pose question, open curly brace, close curly brace after we get answer from the user, and then while answer is less than A or answer greater than D, semicolon. Remember that characters can be treated as integers because they're represented as integers, so we can use range checking code to make sure that a character is within a specific range. So that method should work to pose the question, obtain an answer, and keep obtaining an answer until the user enters an answer between A and D. The problem is we need that answer back in main. And as I said, pose question is Las Vegas. What happens in Las Vegas stays in Las Vegas. How do we get the value of answer back to main? We return it. Methods can return a value to the calling method through a return statement. Quite often, a method produces some work that we need back where we called it. So let's write, after our while statement, return answer, semicolon. You can see that return is a keyword. And Eclipse gives us a red X and helpfully highlights in the method header where we've declared the method as void. If I mouse over the error, it says void methods cannot return a value. But we are going to return a value, so we need to replace that void with the data type being returned. We're returning answer, a character, so I'll replace that void in the method header with char. Okay, one more step. We're returning it, which is like throwing a baseball. How many metaphors can I use to describe one concept? We need to catch that baseball back in main. Pose question returns answer. So back in main, to catch it, I assign answer equals pose question. That is how you catch the return value from a method. You put a variable with an assignment statement in front of the method call so you have a place to store the returned value. So to review what's happening in this final version, execution begins at main, and as we described previously, eventually we end up at our call to pose question. Execution jumps to the method header of pose question, where all of the values we passed in are copied to the parameter variables. We added one this time. We added the scanner, which is a variable, not a literal. We can pass in variables, literals, or more complicated expressions, and the values are copied up to the parameter variables. We go into the method and execute the code, which is now a loop. The method will loop as long as the user doesn't give us a value between A and D. And then once they do, we drop out of the loop and return the answer they gave. Let's pretend they answered A. We then return to where the method was called. Now, previously, that method call stood alone on a line, but now it's the right-hand side of an assignment statement. That method call evaluates to the value returned. As I said, let's imagine that's A. And then that is assigned to the variable on the left of the assignment operator. Now main proceeds as before. I'll run it and enter a few out-of-range answers first. I'll enter X and Y. And now finally I'll enter A. I get the feedback. And I'll enter C. And the program ends. Let's look at the updated structure chart for this version. You can see it looks a lot like the last version, but now I've added a data flow for the scanner going in to pose question. And I've added a data flow for the return value answer going out of pose question and back to the calling method main. You can think of data flows as being like the ports on your computer or phone. You can plug a specific kind of connector into each port, and data will flow in or out. Okay, I know that's a lot. Please remember this is an overview of methods. We will take a deeper dive into parameters and return values, as well as other method concepts in other videos in this lesson. We'll go through them in much more detail so that by the end of the lesson, this should make sense. As usual, I have included some auto-graded exercises in the description of this video, allowing you to modify the program step by step as we did in the video. And the different versions of the program have been uploaded to my GitHub repository with a link in the description. When you're feeling confident with the concepts in this video, or when at least you have a general idea of what's going on, you're ready to move on. As always, have fun and keep coding.